Dear students, see the next one in 11th standard motion in the straight line chapter. The next topic is instantaneous speed. So you know that average speed initially. Average speed means there is total distance covered divided by the total distance. Total distance covered divided by total time taken. So that is average speed. Okay. So in that average speed also there are two different types of cases we discussed. Okay. Right. So now this is instantaneous speed. Okay, instantaneous speed it's very small. Okay, say for example, let us take it is a point. Okay, right here. Listen. From the point it is the A, then it is the B. Okay. Now, then one object is moving in this direction. Okay. So, from A point to the B point, the average velocity, you know how to calculate. Okay, even B A to B or B to C or anything, that average velocity you know. Okay, but now I'm going to reduce. Okay, the time factor I'm going to reduce now because let's take in this moment when the object is to reach here. Okay, when the object is to reach this point, then what about the um, that speed? Okay, so in this moment, in this incident, that time factor I'm going to reduce. Okay, time factor, you know, A to B it's take 5 minutes. Okay, for example, A to B to take 5 minutes. So the 5 minutes, this much distance is covered. Okay, so now now I consider this point. So in this point, to cross in this point, maybe the time factor is more minute. You understand? Okay. For example, the stopwatch is here. The stopwatch travel from here to here. It's take 5 minutes. For example, it's take it's take 1 minute. Okay. Now I mention one point. Okay. For example, this ring. Okay. Now the stop is to cross this ring. To cross this ring, the ring alone. Okay. To cross this ring, it's not 5 minutes. It's okay. It's maybe 1 second. Okay. It is 1 second. Now in this ring also, on the ring also. Okay, it is the ring. It is the surface of upper surface of the ring. Okay, on the ring also, just is mentioned, just taken as only at the center. Okay, so in that center, how much? What about the duration? Okay, okay. So again, maybe it will be less than 1 second. Okay, so this A to B is taking, for example, 5 minutes. Okay, if you cross this particular point, it takes only 1 second. Again, that point also, it is more minute. More minute means what is the meaning? If the distance is reducing, okay, that time factor also is reducing. So that time factor is tends to 0. 0 pakkatala. So in that range, in that time one speed, that is instantaneous speed. Okay, so now I read the statement. Okay, see that the speed of an instant, is defined as the limit of average speed as the time interval delta t becomes infinitively small or approach to 0. So the time factor is approach to 0. Okay, time factor approach to 0. Okay, up nearly 0 time la evalo distance cover. You understand? Yes, that is instantaneous speed. Okay, so that ratio, that distance and that time ratio, that is that instantaneous speed. See that. So mathematical expression will be helpful to you. So mathematically we can write as that the instantaneous speed at any instant of time is expressed as, that is instantaneous speed, that is SI, instantaneous speed is equal to change in position then divided by the change in time. The time factor is what? Tends to 0. Maybe this is taken as delta t. This is delta t, but delta t is going to reduce as 0, nearly close to the 0, approach to 0. Okay, so 1 minute this much distance cover, half minute this much distance. Okay, 10 seconds this much distance. 1 second is very long, very minute distance. Okay, so 0.1 second, that is instantaneous. So we can write as the instantaneous time, that is the instantaneous speed. We can say the change in position with respect to the time, instantaneous time. Okay, so at any instant, okay, so we can say that mathematically instantaneous speed at any instant of time, instantaneous speed at any instant of time, we can write as, that is SI is equal to delta S divided by delta t, but the limit, that is delta t, there is a time approach to the 0, that is the meaning. Okay, so we can write delta S divided by delta t. Okay, I want to write simply means you can write as instantaneous speed is equal to ds divided by dt, that is the meaning. Okay, right, so here ds is nothing but what? Ds is nothing but what? Very small distance, very small time, covering distance is very small. So that only mentioned here, that is del ds is nothing but distance covered in the time dt. Okay, so ds divided by dt is nothing but, that is that there is a differential coefficient of s with respect to the time t. Okay, s difference, actually s means what? That is the position, that is the distance divided by time. So that changing value, that is changing position with respect to the time. So that is, that is the speed, that is that average, sorry, that instantaneous speed. Okay, so we can say, you remember this point is very important, that instantaneous speed at any instant of time is expressed as, that is SI is equal to the limit time factor tends to 0 through delta S divided by delta t, or SI is equal to ds divided by dt. Okay, this is instantaneous speed. Okay, thank you.